Hello and welcome to this video on types of data. So essentially there are two types of data. There's qualitative data, I don't know anyone who calls it categorical, which is non-numerical values such as colour, and then there's quantitative data which takes numerical values. Within quantitative we can either have discrete or continuous variables. So discrete variables only take specific values such as shoe size or the number of children you have, whereas continuous can take any decimal value possible within a specified range. Okay, now note it says on the left that while discrete variables only allow specific values, the range could still be infinite. So for example, if you were tossing a coin and you wanted to count the number of heads you got until you got a tail, in theory you could go on for an infinite time, but it's still discrete because it will be a value which can't take any decimal value within a specified range. So here's a very exciting activity for you. We have 22 variables, and for each one I would like you to state whether it's qualitative, i.e. a non-numerical value, or quantitative, a numerical value, and if it is quantitative, a numerical value, whether it is continuous or discrete. So please pause the video and the answers will be on the next slide. I'm not going to go through all the answers. Please pause the video and check the answers you've got. I am just going to mention the one that says age of a year 12 student, because as you can see, it says it's usually described as quantitative discrete. And that's because if you ask a year 12 student how old they are, they're probably going to say they're 16 or 17. They're not going to say they're 16.54321789, whatever. Okay, but theoretically, of course, if you were to count the number of, milliseconds or whatever since you were born, then you're going to end up with a more precise value. Okay, but age is normally described as quantitative and discrete. Okay, if you have any questions about any of the other answers, please feel free to contact me and ask why you disagree. Here are some more terms on your glossary sheet. We can see that we have a very small table with only 2 rows in it of data. So we have a weight. I don't like the fact it says in kilograms, of course, because maths and physics teachers don't like that, but exams seem to, because weight should be in newtons. So we have a weight between 0 and 20, which could be equal to 0 but can't be equal to 20. And we have another row which says that the weight has to be between 20 and 70, and it can be equal to 20, but it can't be equal to 70. And that's exactly the same way that information was displayed for you at GCSE, whether you're drawing a cumulative frequency graph or a histogram, or whether you were estimating the mean, you would always have these inequalities in your table. So we know on the left data can be grouped for conciseness, okay, but we do lose the exact original value. So we know that there are 3 values between 0 and 20, but we don't actually know what they are. If we were estimating the mean, we would assume they're all averaging out to 10, but we don't know that. So looking at the definitions, it says this is known as a class interval. So 0 less than or equal to w is less than 20 is a class interval, as is the one it's pointing at. 20 is less than or equal to w is less than 70. So anything written like that is a class interval where we have certain values within that class. The lower class boundary and the upper class boundary are simply the numbers at the lower end and the upper end of that class. So for 20 to 70, the lower class boundary is 20 and the upper class boundary is 70. For 0 to 20, the lower class boundary would be 0 and the upper class boundary would be 20. The midpoint easily worked out. There's a couple of ways you can do it. So you could add together the lower and upper class boundaries and then divide by 2. So that would give us 90, and 90 divided by 2 is 45. Alternatively, you could work out the class width, as we'll do in a minute, which is 50. If you halve that, you get 25. So the midpoint is 25 more than 20 and 25 less than 70. And yes, the class width is simply the width of the class, as its name suggests. So if the upper class boundary is 70 and the lower class boundary is 20, then the class width is 50. Here is another exciting activity, keep you occupied. So this time we have a slightly bigger table with 4 rows of data, and this one is about time. The frequencies are completely irrelevant for this activity. So we've just met the idea of the lower class boundary, the upper class boundary, the midpoint, and the class width. And you have 16 questions there based on the table to answer. Again, please pause the video. The answers are on the next slides. And again, I'm not going to read them all out, but if there's anything there you disagree with, then feel free to contact me and asked. Now, I don't think this information is actually mentioned in chapter 1, but when you get further through the stats topic in year 12, you see them writing data in a slightly different way from the way you're used to at GCSE. So they don't use inequalities. So here we have a table where the length is L measured in kilometers. And the first class, it says it goes from 3 to 6 with a frequency of 1. The second class goes from 7 to 11 with a frequency of 2. But notice that there are gaps between the data. So if I was, let's say I had a journey of 6.2 kilometers, where would I put 6.2 kilometers? Because technically, if you're treating 3 and 6 as the lower and upper class boundaries, then 6.2 has nowhere to go. So what actually happens with this type of table is that we need to close the gaps. So the first bar actually goes up to 6.5, and the second bar starts at 6.5. If we were writing it as inequalities, we would probably write for the second bar, 6.5 is less than or equal to L is less than 11.5. Okay. Now, we do have a bar at the beginning. So the upper class boundary for that is actually 6.5 because of the gap. And because of that, we would actually start it at 2.5 to have half a unit either end. If it started at 0, then we probably wouldn't do that because no one's traveling minus 0.5 kilometers. But where all the values are greater than 0 like this, we would assume that the first class actually goes from 2.5 to 6.5. So that changes the class boundaries. It doesn't change the midpoint because we're adding 0.5 onto each end, so the midpoint hasn't changed. But of course, the class width will be slightly different. So at first glance, we're looking at 3 to 6. We might think the class width is 3, but it's not. It's 4 because it starts at 2.5 and it finishes at 6.5. So in an exam, you may be presented with a table which has inequalities in it, in which case the class width is exactly as it seems, and you do what you did at GCSE. But probably more likely is that you'll get a table like this, which has 3 to 6, 7 to 11 and stuff, and you have to actually fill in the gaps when you're doing it. So the midpoint of 7 to 11 is 9, okay, and that's halfway between 7 and 11, so halfway between 6.5 and 11.5. But the class width of 7 is not 4 because it starts at 6.5 and finishes at 11.5. Just one final thing on this particular table, we can see that one row just has the number 12 in it. Okay, and if we were doing class widths using inequalities, we'd probably say the class width was 0 because 12 is just a single number. But of course, it actually starts at 11.5 and finishes at 12.5. So the class width of 12 is 1. I've asked you to find the midpoints and class widths of the other 3 classes in the table, so just do that for a couple of minutes and then pause the video and then move on to my final slide. Okay, and as we have twice before, here are my answers. And again, if you disagree with any of them, please feel free to contact me and question what's going on. Thank you very much for listening.